All right. Well, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 46 is on your screen. You should be able to do all four problems by now. Problem number one says, solve and allow for imaginary numbers. Equation given, 3x squared plus 27 equals y. Number two, it says graph f of x equals x squared without a table. Then write the rule and graph the transformation if g of x equals a times f of parentheses 1 over b x minus h close parentheses plus k. Parameters given are a equals 1, b equals 1, h equals 3, and k equals -4. Number three says solve by completing the square. X squared minus 8x minus 10 equals y. And number four, it says compute the voltage for the capacitor of the electric circuit. And they give you the given current in amps, which is 24 plus 12i. And the diagram is like a rectangular diagram of an electric circuit. At the top, you have labels for everything. And in the middle, in between, I'm not going to tell you which one is which. You should know by now. So make sure you copy that from the screen. And I'll give you some time to do that. And then I'll come right after to go over. Copy that and go. So let me go over the warm-up. We got number one, and it reads solve and allow for imaginary numbers. So first things first, make sure it's equal to 0. So this is 3x squared plus 27 equal to 0 in order to start solving. So what method do you guys prefer for me to solve this with?
Wait, what was that, Mr. Q?
Which method do you guys want me to solve these with?
Square roots.
Square roots, all right. So then let's get rid of the constant. Here we subtract 27 to each side. That leaves us with 3x squared equals to -27. From there we divide both sides by 3 to leave the x squared by itself. That's a giant 1. We're left with x squared equals to -27 divided by 3. That's -9. And last, we do the square roots because that's the method that we're using. So that leaves us with x equals plus minus. What is square root of -9? Square root of -9. Jaziel. Square root of -9.
3 or plus minus 3.
Plus minus 3 what?
I.
Bam. I agree with you. Bam. So yes, plus minus 3i. Let's go to number two. It says graph f of x equals x squared without a table. By now we should be experts at this one. So but here it goes again. Here's my coordinate plane. And once again, we have x, f of x. And to graph, we usually use the domain -2, -1, 0, 1, 2. And what do we do with each value? Because it's a square, so -2 squared, that's 4. It's about right there. -1 squared is 1, 0, 0, 1, 1, 2, 4. And my original f of x is right there. Okay. And my vertex is at 0, 0. Vertex being either the lowest or the highest point. All right, so then they ask us to write our transformation given these parameters. So I'm going to substitute that in here. So for A, we have 1. For B, we have 1. For H, we got 3. And for K, we got -4. So let me rewrite this. G of x equals 1 times f of parentheses 1 over 1x minus 3, close parentheses, squared because it's a quadratic, and then -4. Let me rewrite this one so that we can use that to transform it now. Do we need to write the f and the 1 anymore? No. So this becomes g of x equals parentheses 1 over 1 is 1x minus 3 squared minus 4. So we're left with two parameters. Where's that going to take us to, Addie? Where's that going to take our original graph to?
Mr. Can you say that again? You were like cutting out for me.
Oh, according to the parameters left in the red transformation, where is that going to take us to?
Oh, 4 down and 3 to the right.
4 down and 3 to the right. That is correct. So instead of taking all the points, I'm going to use the vertex. The vertex right now is 0, 0. I'm going to go 3 to the right and 4 down. So 3 to the right, 1, 2, 3. 4 down, 1, 2, 3, 4. So my new vertex is going to be right there. And if I graph the other points the same, moving them the same way, but if I see that these 2 points are close, 1 up, 1 to the left, 1 up, 1 to the right, so I go 1 up, 1 to the left, 1 up, 1 to the right. These 2 over here are 2 and 4. So 4 up and 2 to the left, 4 up, 2 to the right. So 4 up, 2 to the left, 4 up, 2 to the right. And my new transform function is right there. That's g of x. And just to point out, what's the vertex, the new vertex now? The vertex is at 3, negative 4. And obviously, if you look at the parameters, where do we get that from? All right, hopefully you see it. All right, let's go to number 3. Number 3, it says to solve by completing the square. I'm going to leave that up there for those of you that are finishing up, and I'm going to solve the square right here by completing the square. So I'm going to take x squared minus 8x minus 10. I'm going to equal it to 0. So we got x squared minus 8x minus 10 equal to 0. To complete the square, is it in standard form equal to 0? Yes. What's my next step? Divide by the leading coefficient, which is 1. Divide by 1, I'm left with x squared minus 8x minus 10 equal to 0. From there, eliminate the constant being negative 10. So that means I need to add 10, add 10. We're left with x squared minus 8x, leave an empty space, equals to 10. From there, I need to complete the square. How do I complete the square? Well, I take the coefficient of x right here, and I do plus negative 8 over 2 squared, plus negative 8 over 2 squared to both sides. Let's simplify this. This is x squared minus 8x plus 16 equals to 10 plus 16. What is 10 plus 16? That's 26 on the right side. I bring down everything from the left. 8x plus 16. And now we're going to factor the trinomial on the left side. How do we do that? The shortcut, square root of the first, x, square root of the last, 4, sine of the middle, minus, and squared equal to 26. And lastly, we take the square root of the left and the right to get rid of that squared. So we end up with x minus 4 equals plus minus square root of 26 because this is not a perfect square. Solve for x. That means I need to add 4 to each side, add 4. So x equals 4 plus minus square root of 26. And then let's write our 2 solutions. X sub 1 is 4 plus square root of 26. And x sub 2 x sub 2 is 4 minus square root of 26. And that is our solutions. X-intercepts, zeros, roots. So if you notice, they are still real solutions, but these are known as what? Complex, because they're a little bit more complex, and I'll elaborate more on that as soon as we get started. All right, and last but not least, number 4, it says compute the voltage of the capacitor given the graph. Okay, so hopefully with your home play over the weekend, it was enough practice. What is the formula to find the voltage of anything? It's V equals I, which stands for the current, and Z, which stands for the impedance. The current flowing through a certain component, in this case, capacitors. So notice here, there's 2 capacitors, here and here, and 2 ohm, 3 ohm, so that it becomes what? 5 ohm, which is 5I. However, if it's a capacitor, it's a negative imaginary. All right, we're going to multiply that times the current being 24 plus 12I, and all that equal to V for the voltage. Let's distribute. Negative 5 times that. First term, negative 5 times that. So we get voltage equals, Negative 5 times 24 is negative 120i. And negative 5 times 12i, that's not positive, it's negative 60i squared. Well, sorry, let me get it closer over here. Negative 60i squared. What do we know about I squared, guys? We need to substitute what? Negative 1 right there. Therefore, what is negative 1 times 60? That's positive 60, bring down the negative 120i, and that's the voltage going through those capacitors. Hands if you got that. All right, good, yeah. So just FYI, because you're gonna have one of these on the party coming up. Let's go. Y'all ready? Let's go. Just doesn't know. Yes, you are. Got plenty of practice. Let's go. All right, let's move on. So we're done with warm-up number 46. Our agenda says warm-up number 46, complex numbers, home plate for tonight, pages 146 and 147 only. Heads up, it's the home plate for tonight is very robust, you know, just to put it in a nice way. So make sure you stay focused throughout the session, okay? So those of you that are doing whatever it is on the side, social media, or if you're among us or whatever, cut it out, my goodness. All right. Move on. Our synchronous session for today is UNJ74. UNJ74. Make sure you're keeping up with your synchronous sessions. All right. All right, your home play from the weekend was pages 136, 130, 135, 136. Make sure you turn that into Canvas, please. And once again, your home play for tonight is pages 146, 147 only. Reminder, tutoring right after lunch. Be there or be elsewhere. That makes sense, right? All right.
Mr. Q,
Yes.
what was the code?
Code again, UNJ74. UNJ74.
Thank you.
You're welcome. All right. Y'all ready? All right, here we go. Our objective for today, I can identify complex solutions to quadratic equations. I can identify complex solutions to quadratic equations. If you notice, the word complex is still there, which means we're still in the same concept of complex numbers, yes? But now we're finding solutions in quadratic equations by looking for complex numbers or complex solutions. So here we go. So complex numbers. In your own words, give me a definition, one example, one unexample, and a hashtag. You got 1 minute. Ready? Go. So in your own words, you should have said something to the effect that one real, one imaginary, an example, non-example, and a hashtag. Yeah? Yes, Mr. Q. All right, good. All right, so set that aside. So just to be clear before we move forward, check this out, guys. They're going to be asking you tonight in regards to identifying real solutions or non-real solutions, okay? So writing utensils down, look up to the screen. I just want to make sure that we understand what we're looking at when we end up getting a solution at the end, if it's real or non-real. So here we go. Real solutions, look up. All right, so here we go. So it says, identify real solutions in a quadratic equation. So here's a simple one. X equals plus minus 2. One solution is 2, the other one is negative 2. Are we there so far? Yes? All right, how about this one? X equals plus minus square root of 5. What are my solutions? X sub 1 is square root of 5. X sub 2 is negative square root of 5. These are still real solutions. Another one. If I gave you X equals 3 plus minus square root of 7. What are my solutions? X sub 1 is 3 plus square root of 7. And the other one is x sub 2, which is 3 minus square root of 7. All of these, guys, look up. All of these are what? Real solutions. They are what? Real solutions. Now, if you notice, out of those three, which is the most simplest one, Jaziel? Which would you say is the most simplest solution?
The solutions for x equals plus minus 2.
Yeah, this is the simplest one. That means that these that end up with a square root are a little bit more complex. Is that correct? They're a little bit what? More complex. That's why at the end when they ask you in questions like allow for complex solutions or whatever the case, that means that you're gonna be able to leave your answers like this in a square root form. Now, some of you are like, Mr. Q, isn't this not a real solution, negative square root of 5? Well, what's inside of the square root? It's a positive number, isn't it? Yes, that's why it's still a what? Real. Doesn't matter if it has a negative outside, as long as there's a positive number inside of the radical, it's still a what? Real solution. Okay, so let me go to the next part. The next part is non-real. 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 If they are non-real, guys, look up. If they are non-real, that means they are what? Check this out. They're like, what is he doing? I'm creating a little rainbow above myself like this. Like SpongeBob, you guys remember SpongeBob now? Imagination. Anyways, if they're not real, then they are what? Imaginary. Imaginary numbers. Okay? For example, let me show you the first one. X equals plus minus obvious 3i. Why is it imaginary? Because it has an I right there, Mr. Q. Actually, there's two I's. X sub 1 is 3i and x sub 2 is negative 3i. Here's another non-imaginary. X equals plus minus square root of negative 7. What's another way of writing square root of negative 7? Well, you can write it like this. X equals plus minus what? I square root of 7. Does everybody know where I got I square root of 7 from? Yes, by now you should know square root of negative 7 is the same as square root of negative 1 times square root of 7. That's where we get this. And how many solutions? Two of them, positive and a negative. How about this? X equals 2 plus minus square root of negative 5. What would be my two solutions? My two solutions are x sub 1 is 2 plus I square root of 5, and x sub 2 is 2 minus I square root of 5. Now, all of these guys are what? Non-real. What are they? Non-real. Why non-real? Well, this one has an imaginary. These have what? Negative inside of the square root. Whenever you end up at the end with a negative inside of the square root, that means it has to be what? Imaginary. Like this. Imaginary. So we're like, Mr. Q, how do you know that we watch SpongeBob? Well, just a hint. I have like something tells me in the force. Anyways, so we good, right? Imaginary, non-real, right? Or non-real, imaginary, and real. Okay, let's move on. So copy this one. Example 1. Create a coordinate plane on the right side from negative 10 to 10. And it reads, example 1, graph and state how many real solutions. The equation given, y equals 2x squared plus 4x plus 1. Copy that really quick. 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So they're asking us, look at the statement here. It says graph and state how many real solutions. Now in the past, we solved quadratic equations by graphing, and the question was solve by graphing. Are they asking us to solve here? No, they're not asking us to solve. They're asking us to identify how many real solutions in this, okay? Now, one way of identifying the real solutions or the solutions is by graphing this using a table and graphing this exactly as it is. And we know how to do that, right? With a table with -2, -1, and so on and so forth, substituting values and such. However, I'm gonna show you a graphing strategy, look up please, so that you can identify how many real solutions, but not finding the solutions, but graphing it so you can identify the real solutions, okay? Now this is gonna progress, and you're gonna have to start thinking outside the box as we go. Don't say it out loud if you see it. And then at the end, we're gonna answer a question all together, okay? Here we go. Write your utensils down, look up to the screen. I'll let you copy right after. Stay focused, please. First things first, I'm gonna set this equal to 0, because I'm gonna be, let me make this equal to 0. So it's 0 equals 2x squared plus 4x plus 1. Now look what I'm gonna do. I'm gonna get rid of the constant. So I'm gonna do -1, -1, and that leaves us with -1 equals 2x squared plus 4x. Okay, so stop writing so that you guys can follow me in your thought pattern. Here we go. If you notice right now, we're left with the first two terms of the original and the constant, we send it to the other side. You guys see that, yes? Okay, where this is taking us is that we're getting closer to a session or a lesson on systems of equations, but involving quadratics, okay? Now, what does that mean, Mr. Q? That we're gonna be solving stuff that is a system pretty soon. So this is getting us closer there. So look, if I was to write this as a system, it would look like this. Bracket, there it is. This side of the equation, which is -1, that would be my g of x, which is -1. The right side of the equation, that would be my f of x, which is 2x squared plus 4x. This with a bracket, and when they give us two or more equations inside of the bracket is known as a system. For those of you that have been with me before, you've seen this before, yes? Yes, Mr. Q. Now check this out, look up to the screen, stop writing. If I was to ask you to solve this system by substitution, we would substitute the -1 here for f of x, and we end up with this, and then we know the different methods of solving quadratic equations, right? Okay, now check this out. Before you copy this, now I have two functions, a g of x and an f of x. So what I'm gonna do, I'm gonna graph to find out how many real solutions in this equation. So first I'm gonna graph g of x equals -1. G of x equals -1 is basically a linear function. It's a straight line. And the number there is actually representing the y-axis. So y-axis is right here, -1 is right there. So if I graph a straight line going through there, it looks something like this. That's my g of x. Copy that, and then we'll do the other as soon as you're done. All right. So we took the original equation, set it equal to 0. The constant, we sent it to the other side, and then we said this is a system. Here's my system, g of x, f of x. Okay. So now I'm going to graph f of x equals 2x squared plus 4x. Do we know how to graph that? Yes, Mr. Q. So let me get my table here, x, f of x. And what domain do we usually use? -2, -1, 0, 1, 2. Okay. So I'm going to rewrite this one right here. I'm going to do 2 parentheses squared plus 4 parentheses so that you can see the substitution, and we're going to do the rest in our noodle. Okay, here we go. What is, if I substitute -2 in here, what is -2 squared? 4. What is 4 times 2? 8 plus. What is 4 times -2? 4 times -2 is -8. What is 8 minus 8? 0. Let's do the next value. -1. What is -1 squared? 1. What is 1 times 2? 2. So let me write that there, 2. Plus 4 times -1, that's -4. Okay, so what is 2 plus -4? That's -2. Next value, 0. What is 0 squared? 0 times 2, 0. 4 times 0, 0. 0 plus 0 is 0. Next, 1. What is 1 squared? 1. 1 times 2 is 2. Let me write that right here. Plus, what is 4 times 1? 4, and that is 6. And last but not least, hold on, I think I messed up this 6. 6. Hi, good morning. 6, there it is. Next one is 2. So 2 squared is 4 times 2, that's 8. Plus 4 times 2, that's 8. 8 plus 8 is 16. Let's graph this. -2, 0. -2, 0. It's right there. -1, -2. -1, -2. 0, 0. 1, 6. And 216 doesn't fit on mine, but it's way up here. Okay, so let's graph this from left to right. It's a parabola. There it is. Arrows. There it is. Okay. All right. So by looking at this, look up, guys. I see this black parabola. I see the g of x, which is a straight line, and I can tell you for sure that for this equation, y equals 2x plus 4x plus 1, it has 2 real solutions. 2 real solutions. You're like, you can tell that by this black graph of the parabola and the blue graph of g of x? Yes, Mr. Q. Oh, I think I get it. Don't answer the question. Don't answer the question. Oh my goodness. Let people think. Let's do another equation. And I'm trying to elaborate this in your noodle. Here we go. What if I gave you this next equation? Y equals 2x squared plus 4x plus 2. What do you guys notice different from the first equation to this equation? What's the only thing that's different? Alberto.
You added 1.
Okay, but what's different? I'm saying, what is different from one to the other? You're right, but I'm saying, what do you see different? What's so obvious?
That you can simplify them.
Okay, close, but what is obvious that's different from one to the other, guys?
It's a 2 instead of a 1.
It's a 2 instead of a 1. Okay. If that's true, who can give me the g of x for this second equation? Who can give me the g of x?
-2.
-2. Thank you, Danny. And if you look at it, do we need to write the other one down here? No, because we know that the other one is pretty much the same. We're left with the 2 terms, which is the same of the black graph. We don't need to regraph that. But let's graph g of x equals -2. Here's -2. And let's graph our red line going through there. That's our new g of x. So for this equation that I just gave you, y equals 2x squared plus 4x plus 2, I can tell you, look at this black graph and the red graph, I can tell you this one has 1 real solution. By now, you should be able to get that question that you had in your noodle answered. But for some of us still not clear, let's do one more. Here we go. What if I gave you the equation y equals 2x squared plus 4x plus 3? Who can give me the g of x for that one?
+3.
Close.
-3.
-3, that is correct. So we write g of x equals -3. So if I was to plot that here, graph my green line through there. Look at the black graph, which is the first two terms, 2x squared plus 4x, which is that one, which is a parabola. And this one, I can tell you for sure, this has no real solutions. Okay, so the question is to you the following. If I was to give you this parabola, and I said this parabola is the first two terms of all of these equations, and then I gave you a different number for the constant, would you be able to tell how many solutions just by looking at it? If it's yes, how would you determine if it has how many real solutions, if it has any? How would you determine that, Mia? What do you think? How do we know? Look, the black one and the blue one, this one had two solutions. The black one and the red one had one solution. The black one and the green one had no real solutions. How can we say that? How would we determine if it has real solutions? Let's see. Help her out, Hayden. How would we determine if it has real solutions?
by seeing how many physical points it has on the line,
By seeing
like how many points it goes through.
how many points, and the word is intersect on the graphs. Yes. Look at this black graph. How many times does it intersect the blue graph? 2 times, so that's why it has 2 solutions. Look at this red one. How many times does the black graph intersect the red one? Only 1. It barely touches. That's why it's only 1 solution. How many does this black graph intersect the green one? Does it intersect? No, that's why it's no real solutions. And that's how we determine. So for your home plate, guys, you're going to have a couple of questions like this. They're going to give you the actual graph, and they're going to give you an equation that looks very similar to the original, and they're going to ask you how many real solutions just by looking at it. Would you be able to determine that? Yeah. Show me your fingers. I'll come to you with answering those questions with ease. 1 being the highest, 5 being the lowest. I mean, 5 being the highest, 1 being the lowest, 5, 5, 5, 5. Okay. All right. Let's move on. Here we go. Next. Now that we know how to find the solutions, how many solutions, real solutions of a quadratic equation by graphing, let's do it without graphing. Example 2, copy this one. It says, state the number of real solutions without graphing. Y equals 2x squared plus 4x plus 1. Copy that, please. Now this one we're going to do together since this is something that we've been doing ever since Algebra 1. Let's go. So those of you that were with me, I kind of hammered this one out pretty well. Those of you that weren't, hopefully your teacher did hammer this one out pretty well. So here goes the steps. I'm going to give you the steps on the right side. Step 1 needs to be in standard form. Step 2, we need to identify ID, A, B, C. And step 3, we need to substitute A, B, C into the, let's see if you remember this word, discriminant. You're like, I kind of remember Mr. Q, but yeah, so we're going to do this one together to make sure we got it. So here we go. Is it in standard form? Yes, except for this had to be equal to 0. But if it was in standard form, let me write my standard form underneath with variables. So it's 0 equals ax squared plus bx plus c. So is it in standard form? Yes. So can we identify, so we're done with step 1. Can we identify A, B, and C? Yes. A is 2, B is 4, and C is 1. Does everybody see where we got that from? Yeah, right here. Okay, so we're done with step 2. Step 3 says substitute into the discriminant. You're like, what is that, Mr. Q? Let me show you. Look up. The discriminant is, look up, b squared minus 4ac. Where did that come from? Well, it comes from here. X equals minus b plus minus square root b squared minus 4ac over 2a. Do you need to write the quadratic formula all the time? No. What is it that we need? Only the discriminant, which is inside of the radical. So I'm going to write it over here again. B squared minus 4ac. There's my discriminant. What is step 3? Substitute in there, and let's simplify. So let's see. Parentheses squared minus 4 parentheses parentheses. What is b? B is 4. It goes right there. A, 2, C, 1. Let's simplify. Let's see. We got 4 squared is 16. Negative 4 times 2 is negative 8 times 1. That's negative 8. And then what is 16 minus 8? That's 8. And I'm going to write 2 real solutions. And you're like, how did you determine that, Miss Q? Let me show you. Look up. Write this table down. I'm going to write discriminant. And on the right side, I'm going to write real solutions. Here we go. Here goes the little guide as to how you're going to know if there are real solutions without graphing. If you end up, look at this number. What kind of number is it? It's a positive number. If you end up with a positive number, you're going to have 2 real solutions. If you end up with a negative number at the end, you have none or no real solutions. However, if this number, instead of being positive or negative, the other option is 0, then you end up with 1 real solution. This is what's going to help you determine the real solutions in the quadratic equation. And how do you do that? So look, where did we get this discriminant from? The square root, didn't we? So watch, look up. Another way of understanding this is if I write a square root right here. If I have a square root of a positive number, how many answers do we get? 2, a positive and a negative. Is that correct? Yes. How about this? If I have a square root of a negative number, what kind of number do we end up with? Imaginary. Imaginary. That's why it's no real solutions. And last, if this number was a 0, what is square root of 0, guys? 0. That's why it's only what? 1 solution. 0. Show me your fingers. I'll come to you with this. 4s, 5s, 5 5s, 4 5s. Okay. So let's do another one just to make sure we got it. Once again, here's the process, and make sure it's the standard form. Identify A, B, C, and then substitute into the discriminant, simplify, and then see what kind of solution we get. All right, here we go. Let's go to example 2C. It's y equals 2x squared plus 4x plus 3. Example 2C. Let's see what you get. Bam. Copy and go. Man, that was a little bit off key right there. All right, here we go. So, first things first, is it in standard form? Yes, Mr. Q. Okay, so then let's identify A, B, and C. So let's see, 0 equals ax squared plus bx plus c. So A is 2, B is 4, C is 3. Okay. Substitute those into the discriminant. What is the discriminant? B squared minus 4ac. So let's see, I do parentheses squared minus 4 parentheses parentheses. So let's see, we got B is 4, A is 2, and C is 3. So what is 4 squared? That's 16 minus 4 times 2 is 8 times 3, that's 24. So what is negative 24 and 16? That's negative 8. So no real solutions. Hands if you got that. Good. All right, show me if you're how come you are with these. Yeah, 5, 5, 5, 4. Yeah. So once again, now we have two methods as to identify how many real solutions we have. We do it either by graphing like we did at the beginning, or this one without graphing, okay? So that's gonna be almost half of the work of your home plate tonight. Let's go to the last problem. Ready? Here we go. Copy this next one. Example Q. Oh. It reads, solve by completing the square and state whether the solutions are real or non-real. And they give us 2x squared plus 12x minus 32 equals y. Now, by now, you should be able to do this one by yourself since we've been doing this on the warm-ups for the past whatever weeks. Yes? Yes, Mr. Q. You see? That's why I give you guys plenty of practice before we get to the session. Thank you, Mr. Q. You're welcome. Man. All right, so let's see. Let's do this one together. Step 1. Is it in standard form? Let's see. From highest to lowest degree, yes, but it has to be equal to 0. So I do 2x squared plus 12x minus 32 equal to 0. Okay, next. Divide by the leading coefficient. What's my leading coefficient? 2. Good. 2 divided by 2 is 1x squared. 12x divided by 2, that's positive 6x. 32 divided by 2 is negative 16, and all that equal to 2 divided by 0 divided by 2 is 0. Step 3, eliminate the constant. What's my constant? Negative 16, so I add 16, add 16. We got x squared plus 6x, empty space, equal to 16. Step 4, let's complete the square. How do I complete the square here? Oh, well, I add 6 over 2 squared to each side. 6 over 2 squared to each side. So x squared plus 6x plus 9 equals to 16 plus 9. The right side, you can simplify to 25 equals 2. Left side is x squared plus 6x plus 9. Okay. Next, I need to factor the trinomial. How do I do that? Shortcut. Square root of the first term, x, square root of the last term, 3, sine of the middle, plus squared equals to 25. Next, take the square root of each side to get rid of that squared on the left. So we're left with x plus 3 equals plus minus square root of 25 is 5. Solve for x. Minus 3 minus 3. X equals minus 3 plus minus 5. And last, we write our two equations, x sub 1, which is negative 3 plus 5, which is 2. And x sub 2 is negative 3 minus 5, which is negative 8. Question. They're asking us, tell whether the solutions are real or non-real. What kind of solutions do we get at the end, Danny?
Real?
Real. Let's see. Is 2 a real number? Yes. Is negative 8 a real number? Yes. Yeah, these are two real solutions. X-intercepts, roots, zeros. Real solutions. Real solutions. Once again, when will it be a non-real? When it's a square root of a negative number. Or if you end up with an imaginary number, those will be non-real. Once again, non-real are going to look like that, okay? And once again, I already showed you the different complex numbers that you're going to be getting on your home plate. So show me your, from 1 to 5, how confident you are with completing the square. Yeah, right now you should be at 10 instead of 5, right? So your home plate, guys, I'm giving you plenty of practice with completing the square on your home plate. I think you have about at least 8 of them to do, at least. Why? Because I'm getting you guys ready for the next session that's coming up and also for the pop party. Let's go, pop party. Let's go. All right. Once again, reminder, tutoring right after lunch. Be there or be elsewhere. All right, guys, that's our session for today. Have a good one. And just a reminder, let's see, our asynchronous code is UNJ74, UNJ74. And your home plate for tonight is pages 146 and 147. Have a good one, guys. See you guys later. Peace.
Mr. Q is tomorrow, first and third.